This time we are looking at AB 2009 number 6, which got a really low average score when this was actually part of the AP test. Part A asks us to look at -4 to 4, and we're looking for all values of x where f has a point of inflection. Now, the easy mistake that would be to look at this graph that we've got given to us and notice that it starts off concave up, continues concave up. You might say there is no point of inflection, but we're not looking at the graph of f right now. We're looking at the graph of f prime. To find out where f has a point of inflection, we want to know where the second derivative changes sign. And the second derivative changes sign when the slope of the slope changes. Since we're already looking at the graph of the slope, we want to find out when the slope of this graph changes. And I see one spot right here. The slope of the slope goes from negative to positive. And then once again right here at 0, the slope goes from positive to negative. So we're looking at places where the slope of the slope changes signs. And that happens 2 times. Once at x equals 2, -2, once at x equals 0. Now it's not just telling you to find these values of x, it says justify your answer. And a good way to justify your answer would be saying something like the second derivative changes signs at these values, or you could say concavity changes at these values, or you could say the slope of f prime changes sign. Specifically, you could say the slope of f prime changes from negative to positive at x equals -2, and the slope of f prime changes from positive to negative at x equals 0. Anything like that would probably get you full credit. So I choose to write something like this. F prime changes from decreasing to increasing at x equals -2 and increasing to decreasing at x equals 0. Therefore, x equals -2 and 0 are inflection points. Notice I said f prime changes from decreasing to increasing, not from negative to positive or positive to negative. You could say something changes from positive to negative, but in that case you'd have to say f prime changes from negative to positive at x equals -2, and f prime changes from positive to negative at x equals 0. Careful with the words positive and increasing. They don't mean the same thing. Negative and decreasing do not mean the same thing. Scoring guideline for this one, if you even came up with -2 or 0 as your answers, you got 1 point. Your second point came from your justification. So you had to have the correct answer plus a justification. That's it for part A. Part B, I'm pretty sure, is where people lost a lot of points. We're told to find f of -4 and f of +4. We're going to be working toward 5 of the 9 points right here on part B. F of 4, let's start with f of -4. We don't have a function for f, and we're not going to get a function for f. What we know is that f of -4 should be maybe something like the change from 0 to -4 of f of x. If we calculate that, we're still not going to quite be right. That tells us the change in area from 0 to -4. We have to be real careful and include the initial condition. At 0, we know y is at 5. So we really want 5 plus the change from 0 to -4. Notice the 0 and the -4 are not in the places we like. We'd like to switch those numbers around. So we really can start looking for 5 minus the integral from -4 to 0 f of x dx. At this point, you kind of have to be a geometry superstar to figure out that area. If I look at -4 to 0, looks like I'm looking for this shaded little area here, and I'm not allowed to use a calculator. That might sound daunting, but maybe you realize that this whole piece here is a rectangle. So let's look at that rectangle. That rectangle has a base of 4 and a height of 2. So that rectangle has an area of 8. That little green shaded area, I don't know how to find that area by itself, but I do notice that I have half of a circle right here. So if I take that whole 8 that I boxed in blue and subtract the red area from the circle, I should be left with green. So really what I'm doing here is I'm saying green equals blue minus red. We know the blue is 8. The red we can figure out. The red is a part of a circle. Area for a circle is pi r squared. This time we really want over 2 because it's really half the circle. The radius of that circle we can count is 2. So pi 2 squared over 2, which simplifies to 2 pi. With all that little geometry out of the way, we can now say green equals blue minus red, 8 minus 2 pi. So that was a lot of work when it was already hard to get that integral set up correctly, in my opinion. So our final answer comes out to be 5 minus 8 minus 2 pi. And we could simplify that. You don't have to, but you can. It comes out to be 2 pi minus 3. And that was worth 2 points. Just this part of part B. You got a point for setting up the correct integral, which means if I saw this and nothing else, you would get a point. And you also got a point for your correct value at the end, which you would have gotten incorrectly, of course, if you would have forgotten the 5, or to deal with the 0 and the -4, switching the limits around. That's tough. That's 2 of the 5 points on part B. Next, we're going to look at the points for the second part of part B, which is annoying in a totally different way. We're asked to find f of 4. One thing we can maybe do is figure out the change from 0 to 4 of f of x dx. And this time I don't have to switch the limits around. That's nice. I still need to include my initial condition, however. Looking at 0 to 4, I don't have to be a geometry expert this time. Instead, I have to be kind of a calculus expert, because we're going to do some calculus to find this area. Notice that whole piece is used by the bottom half of the equation. We want to find, really, 0 to 4 of 5e to the negative x over 3 minus 3. And that's going to require a little bit of u substitution. I look at that negative x over 3, and I wish it was an x. Before that, however, I'm going to split this up into 2 problems. One of the problems is a lot nicer than the other. This guy on the right, the 0 to 4 rectangle with height 3, we should know that has a height of 3, a width of 4, so it's really a minus 12. That part's not the scary part. The scary part comes from right here. And that's really only scary if you have trouble with either antiderivatives of e to the x functions, or if you have trouble with substitution. Let's try that with some substitution. We'll let u equal negative x over 3. So du equals negative 1/3 dx. I'm going to move my constant to the other side. Negative 3 du equals dx. Now I'm going to rewrite what I'm highlighting right here. That's going to get rewritten using my u substitution. 5 still stays on the outside. Negative 3 joins the 5 on the outside. So I'm left with negative 15 on the outside. e to the negative x over 3 becomes e to the u. Dx gets replaced with the negative 3 du. I already put the negative 3 on the outside. Still need the du. And of course, we have to be careful with our limits. We don't want 0 and 4 anymore. We want x to be 0. 0 over 3 is 0. Now we want x to be 4, negative 4 over 3. Now we can find that antiderivative. Negative 15 e to the u evaluated from 0 to negative 4/3. Plugging in our u's at this point, negative 15 e to the negative 4/3 minus e to the 0. Of course, e to the 0 is really just 1. So we have negative 15 e to the negative 4/3 minus e to the 0. Or, sorry, e to the 1. Nope, that's wrong. Minus 1. Now we got to make sure we know what that was actually representing. That was really this integral. So we got negative 15 e to the negative 4/3 minus 1 for that guy. So I have my negative 15 e to the negative 4/3 minus 1 minus 12. And because it would just be too nice to be able to stop there, we have to remember that we just answered that question. So for our final answer, we really want 5 plus that big mess we already got. Negative 15 e to the negative 4/3. And minus 1 minus 12 becomes minus 13. We can simplify that a little bit, but we don't have to. We could call that negative 8. Warning, abort. There's a slight mistake I made. Hopefully you caught it. Going way back to this guy. I plugged in my negative 4/3. I plugged in my 0. I forgot to write a minus 15 in front. Which really makes this minus a minus 15, which really becomes a plus 15, which up above becomes a plus 15, which becomes a plus 3 when I combine the 15 and the minus 12. Please forgive me. I do my best. We can clean up this final answer, and we see 8 plus or minus 15 e to the 4/3. And that was a really long, drawn-out process, and that was worth 3 points. You got 1 point for your correct integral. So even if we would have seen this, I believe you would have gotten your first point. Second point, if you took your antiderivative correctly, meaning use some mu substitution or something along those lines, and 1 point for the final answer, for a total of 3 points on this section of Part B. Part B altogether was 5 points total. Part C is a little bit more friendly than Part B, and not too bad, actually. It's asking you to find out the value where f, not f prime, has an absolute maximum. If you can interpret what this graph looks like and what it's really telling you, you should be able to figure this out. We know that from negative 4 to 0, in fact, all the way until this point here, f prime is positive or 0, mostly positive, which means that the original f is increasing. Again, be careful with those words, positive and increasing. The slope is positive, which means the function is increasing. Saying it another way, f prime is positive, So f is increasing. And if we're increasing that whole time, that means we must have started kind of low and eventually got kind of high. Right here at this point, which is identified for us, by the way, it tells us that value of x is 3 natural log of 5/3. Good luck figuring that out without a calculator, right? At that exact point, the graph starts decreasing. F is negative. F prime is negative, which means f is decreasing. So pictorially, we have something like this. The function is increasing, and then right at that point, it becomes decreasing. So our absolute maximum must be right at that value where f prime changed from positive to negative, which happens to be at x equals 3 natural log of 5/3. Also says justify your answer. And I think a lot of people would say something like f prime changes from positive to negative at this point, therefore it's a maximum. That's a true statement, but that by itself doesn't prove that it was an absolute maximum. I think they might ding you if you're not a little bit more specific. I think you need to be super careful and say something like from x being between -4 and 3 natural log of 5/3, the function is increasing. After 5/3, all the way until +4, the function is decreasing. Therefore, the only place you have any kind of maximum has to be at this x value, 3 natural log of 5/3. Therefore, since it's the only maximum, it's going to be the absolute maximum. I think it's kind of important to get all those ideas out. It's better to say too much than not enough. So maybe you end up with something like this. Talk about why the function is increasing and where. Talk about when the function is decreasing, and mention that that has to be the absolute maximum. That's it for part C. This is worth 2 points. 1 point just for having that numerical answer. 1 point for a valid explanation. That's it. This problem is over. It was probably not too surprising that the average on this one was 2.07, especially because of part